Hello, everybody. Today's lesson is going to be a second lesson on looking at double triangles and seeing how we can apply everything we've learned so far. The first time we looked at two right triangles, we used SOHCAHTOA only. Now we have more tools in our toolbox, so we can start to look at how could we use sine and cosine law as well as SOHCAHTOA to solve these triangles. So let's look at the first example here. It says solve for x to 1 decimal place. So notice that x is this side of the top triangle. Also notice that x is the side of a non-right triangle. So we cannot use SOHCAHTOA in the top triangle because it is not a right triangle. So that would take us to sine or cosine law. And if you notice in the top triangle, there's just not enough information given there right now to use either sine or cosine law. One of the things I do suggest you do is add as many angles to triangles as you possibly can. It might open up more doors. So if we notice here, this is a 32-degree angle and this is 8 degrees. So this angle just right in here would have to be 32 minus 8 or 24 degrees. And if you look at the big triangle, if this angle here is 90 and this angle is 32, then this angle here has to be 180 minus 90 minus 32, which would be 58 degrees. Okay? We could add more angles if we wanted to. If this one here is this one right here, it would be, since it's a right angle triangle, it would be 90 minus 24, which would be 66 degrees. And since that's a straight angle there, 180 minus 66 would make this 114 degrees. So that we have all of that information there. And what it does is it gives us a bit of a chance to maybe see some other perspective. Okay? So we need to get x. And the top triangle only has one side. For sine law, we need two sides. And for cosine law, we need more information as well. So let's see if we can get another side in this triangle. Well, if I look at the bottom triangle, so let's just draw this bottom triangle right now. We have this. We've discovered this is 24 degrees. This is 66 degrees. And I'm told that this is 200. Let's make the hypotenuse, let's call it y. So let's add y here. So we could get y because we do have enough information. So let's use this angle here. If we use this 24-degree angle, this is the adjacent side. We need the hypotenuse. That ratio would be cos. So if we do the cos of 24 degrees, that's going to equal the adjacent side, which is 200, over y. And remember from previous lessons, to get rid of y, we need to multiply both sides by y. So then we have y cos 24 degrees equals 200, because that and that will cancel. And then we're going to divide both sides by cos 24 degrees. And this will cancel. So we have, this is what y equals, 200 over cos 24. Now we are going to round. And again, remember how to do this on your calculator. You will just put in 200 and you'll divide it by cos 24. And that gives us 218.9 meters. That's the approximate answer for y. So now we have this here. So if we think about the top triangle now, we have this being x. We know this y is 218.9 now. We know this angle here is 8 degrees. We know this is 58 degrees. And we know this is 114 degrees. So notice what we have now. We have an angle and an opposite side, an angle, and we need the opposite side. So we can now use the sine law. So it would be the sine of 8 degrees over x equals the sine of 58 degrees over 218.9. And we should put a approximate there because it is going to be approximate since we rounded. Now again, we can do it the long way, or we can cross multiply as a shortcut. This multiplied with this and this multiplied with this. So we get 8 sine 58 degrees equals, and we'll put the number first, 218.9 times the sine of 8 degrees. Now, we want to get x by itself, so we're going to divide both sides by sine 58 degrees so that this and this cancel. Now, this is what we're going to put into our calculator. Now, you have to be very careful here because we want this whole thing to be divided by sine 58. So my advice to you when you put this in is to go 218.9 times the sine of 8 degrees. Then let's push equals. So we get the answer. Now we're going to divide that answer by the sine of 58 degrees. And the approximate answer for x to 1 decimal place will be 35.9 meters. And that is going to be our answer. Okay? So again, before you start these questions, it's good to have a plan. I recommend you put in all the angles. Please remember that you cannot use SOHCAHTOA in a non-right triangle. So that's why we can't use SOHCAHTOA in the top triangle initially. So we get more information using the bottom triangle. It is a right triangle, and we use that to use the sine law. Okay, let's look at another question. Moving on to number 2. So again, we're being asked to find x to 1 decimal place. Again, we have 2 triangles. The big one is a right triangle. The one on the right is a right triangle, but the one on the left is not. So again, if we want to add any angles in here, we certainly could. Since this is 28 and this is 90, this whole angle here then, the whole thing is going to be 62 degrees. And if that's 62 and that's 8, then this little one right here is going to be 54 degrees. Okay? If you want to put any more angles in, you absolutely can. You could put in this angle here if you wanted. That would be 36 degrees. You could put in this angle here if you wanted. That would be 144 degrees. Okay? Does not hurt to put the angles in. Okay, so again, if I look at this triangle, I notice that I need to get x here, which is part of the big triangle, but it's also part of this right triangle on the right side. So again, though I don't have enough information to get x right now, I have angles, 3 angles and and I need a side. I have no sides. I need a side. So what I could see is there a way that I could get this side here? Let's call this side y, because then that would give me something to use to get x. And I notice that in this left triangle here, so if we want to draw that left triangle separate, just to give you an idea, this is 30, this is 28, 8, 144, and this would be my y. I could use the sine law to get y because I have the sine of 8 over 30 is going to equal the sine of 28 degrees over y. Okay? And again, cross multiply. I'm going to get y times the sine of 8 degrees, and I always put the variable in front, equals 30 times the sine of 28 degrees. I'm going to divide both sides by the sine of 8 degrees. And that will allow that and that to cancel. So I'm going to get an approximate answer for y. Again, putting that into your calculator, 30 times the sine of 28 degrees. I'm going to push equals, divided by the sine of 8 degrees. And that gives me approximately 101.2 centimeters for my y. Okay, so now if I think about the right triangle, which I'll just draw here, I now know I need x. I now know this is about 101.2. This is 36, and we said this was 54. Okay, so if I think about that, and let's just go down here, I can use SOHCAHTOA. And I'm going to use 54 this time. This is my adjacent. This is my hypotenuse. Again, that would be cos. So the cos of 54 degrees approximately equals x over 101.2. Multiply both sides by 101.2. That cancels that. So that's what x equals. When we put that into our calculator, we get x is approximately equal to 59.5 centimeters. Okay? Let's move that up a little bit so you can see that. And that is my final answer. So this time, I actually used the sine law first and then SOHCAHTOA. So a little opposite order to the last one. Okay? One more example. Let's go to the next page. Okay? Okay, so it says again, find x to one decimal place. A little bit different triangle this time. We have x being the height that drops down the middle of this triangle. Not necessarily the middle, but drops down from the top to the base. The base is 80. We have 38 and 70 here. So by using angle sum triangle theorem and knowing the angles equal to 180, we know that this big angle is 72 degrees. Okay? Again, if we look at the triangle, let's pick the one on the right with x. We don't have enough information to solve for x right now. We can't assume that the height dropped down to the middle. It doesn't tell us that, so we can't say this is 40 and 40. But we can use sine law, and if we use sine law, I could get this side over here, which would give me a side in that right triangle. So again, if I think about the sine law, I have the sine of 72 degrees over 80, so this angle over this, and it would equal the sine of 70, so we're looking at the huge triangle, over y. Okay? Again, if we cross multiply, we get y sine 72 degrees equals 80 sine 70 degrees. And again, if we divide both sides by the sine of 72 degrees, that cancels that, and there's my exact answer for y, which again we'll put into our calculator to be 80 times the sine of 70 equals divided by the sine of 72, which gives me approximately 79.0 meters for y. Okay? So now if I think about that right triangle, and let's just do a little sketch of that right triangle. We know this is 38 degrees. This is x. We now know this is about 79. We now have enough information to solve for x. If I use this angle here, this is the opposite side, this is the hypotenuse, that would be the sine of 38 degrees equals x over 79. Again, multiply both sides by 79. So there's our answer for x. Again, it's approximate now because we rounded for y, so that we would get for x 48.6 meters to one decimal place. Okay, and there is my final answer. So I really highly recommend for these questions that you kind of plan it out first before you start writing. There are many ways to do these questions. The way I did it is one. There's definitely other ways that you might see. Please just make sure you don't skip steps. Make sure that you have a plan before you start so that you don't have a really, really, really long answer that you don't need to have. Okay? Hope this is a helpful lesson. Good luck with the homework.